Hello, this is Ethan from Dark Zebra. Today we're going to be having a little introduction to the Docker build command, which allows us to build our own images from which we can run containers. The first thing is that we have to create a Docker file. We're going to go into this demo folder. And you'll notice here I have a file called Dockerfile, and that's with a capital D. They should always be named the same. I do not believe there's an option to configure it, so always name it Dockerfile capital D. What that file looks like is it contains an instruction and then an operation code. So it's just a simple all the way down instruction and then the command that needs to be run. The first thing that we have here, and you're going to have this as the beginning of every single Docker file you write, is a from instruction. And in our case we put from, and we're choosing the image, the base image upon which we are basing this, which is Debian and then the latest tag. And then you really should add in a maintainer tag as well, which just says who is the person to contact or the entity to contact about this. And I want to cover something before we get started about what's called context. When we start building an image, the command is just Docker. We're going to do the help here. Docker build. And it's just Docker build our options and then a path or URL. And then you can do some other options which we probably won't talk about right now, but other than the tag option we'll use. So what I would do is say Docker build, and I'm going to do a build real quick here. First, I want to show you what images that I already have on this machine. And all I have is Debian. And if I do Docker images -A, that will show all images. And I actually have 3 here, but they are all part of the Debian image. So they really are just the Debian image. So we're going to actually build this Docker file that has just the from Debian latest and the maintainer in it. And the command is Docker build. We're going to add a -T, which is a tag name, and we say a username / demo or whatever you want to name it. You can name it just plain demo, and you can add in a tag as well, like latest or version 1. But if you're going to be contributing to any kind of repository, it's a good idea to use the username / image name standard there. And you'll notice in Docker that a lot of the images follow that standard unless they're base images. So we're going to do Dark Zebra /demo. We're going to actually add a tag called v1. And then we're going to add in the image or the directory which we will build into the image. And in our circumstance, we're going to say just dot, which basically means the present working directory. And you can see here it ran these 2 commands. Added a from, gives you a container ID or an image ID, and then it runs the maintainer. An important thing to remember in this is that what the Docker build command does is it actually, the command line does not run the command, the build. It actually sends it to the Docker daemon or daemon, which then builds the image and stores it in the Docker daemon. What that means is that everything inside of our Docker folder, image folder, gets copied over to a location that the Docker daemon uses. That's called our context. And you'll notice here that it says sending build context to Docker daemon 16 kilobytes. If I do something like paste in this command, which is basically will create a 32 megabyte empty file. And now when I run the command docker build, you're going to notice a couple things. First, it's going to take longer because it has to copy that 32 megabyte file over. So anything in your context directory gets copied over. So obviously, don't put really big things there that don't belong there, and don't try to build Docker images on your root directory, or you're going to run out of hard drive space. And it's going to take a long time to copy things. So just be aware of the context of your build directory. Another thing here is, this time when we built, it said using cache. When we build a Docker image using a Dockerfile, every command in the Dockerfile or every instruction is run inside of a container. And if that returns successfully, then that container is stored as the new image. So in our case, we have step 1, and it created this hash to identify it. And then step 2, or step 1 actually, it created this hash. But you'll notice that these are exactly the same as the ones before. If it already has that command, it will just use the container and the image already created for that. And if we look at Docker images, and we're going to list all of them, you'll notice now that I have the image ID matches this image here. This image ID created in step 1. But I also have this Debian image ID which matches the step 0 image ID. So every step along the way we're going to create new images, and as they succeed we will build layer upon layer as we run each instruction. And this caching will allow us to build other environments that are maybe very similar, or other images that share a lot of environmental stuff without needing to recreate all of the steps involved. So which brings us to the first part here, which is we're going to actually run some commands in our image. And we're going to uncomment this. And what we're doing is running 3 commands while creating this image. Each one of these instructions will create a new container, and when it completes will become the image. First thing we're going to do, because we're running on Debian, we're going to update apt-get so that it can install some software. This Debian front end is just an environment. I want to set it temporarily, and it will just make sure that I do not get any errors about the terminal or about the screen output. And then I, of course, just run apt-get install, and I do it quietly and automatically answer yes, and I install apt-utils. I'm going to do the same thing down here, and I'm going to install htop, which is a process monitoring, system monitoring utility. And then I'm going to clean out apt-get so that I don't store that extra space on my image. So let's save this. And now run our build command again. This time we're going to call it v2. And I still have that image and that file in there in my context, so it copied all 32 megs over. I need to make sure and remove that next time. Now notice this first part ran really quickly. It used the cache. Now it's running apt-get update, which will take just a minute. There we go, reading package lists. We're getting very close to having this all installed. And we're done. So let's look at a couple things. First of all, Docker images -a. I now have a couple of other image IDs saved below this. These are for each of the steps I took. And if I believe we look at we'll see that step 4 matches our current V2 image ID. And because we added tag, we still have Dark Zebra Demo V1. Now, if I run that exact same command again, it will run very quickly because every one of these steps has been cached. So remember when you're building images to do things in your Docker file that are very standard among them, so all of your Docker files and images can be built on the same caches and the same layers. Now, because this is run, I can actually enter this. We're going to run it, docker run -it. I don't want to remove it because I don't want to keep it hanging around. And I'm going to say Dark Zebra Demo. We're going to run bash on it. And it could not find it locally, which means I need to add in my version. There we go. So I forgot my tag, and so it was looking up in the global repository, which it couldn't find. So it's probably a good idea to have a default Dark Zebra /demo, which will get tagged as latest. And in fact, I'm going to do that right now. We're not going to do a V2, we're just going to do a default. And once again, it uses the cache, but this time you'll notice I now have Dark Zebra Demo and it's tagged at latest. And what that means is now when I run the command without the tag, it will automatically look for the latest image tag. And that's going to be pretty standard across. So remember that latest is what's looked for by default in the local image repository. So I am now in my Docker container for Debian, and I've installed htop. So if I just type in htop, I get my command here. You'll notice I don't really have any processes running because it's a Docker container other than bash and htop. I'm going to exit out of this and then exit the container, and I should not see any containers still lying around. So the next step is we're going to execute, we're going to talk about the command. You saw that we just ran htop. So last time I explicitly ran the bash command. But let's say that I want to have a default command, something that is automatically run on the container if they do not pass in a command. So I added in htop, which we installed. So when we run our container and don't pass in a command, it will automatically run htop. And so this time, hit enter, and it automatically begins htop. That's what command does. I can still pass in an alternate like bash, and I have a bash shell. I can also pass it in as a in the format. There are several ways you can do this. You can just pass it in as a string ls-l, or you can pass it in as just ls-l like that. But the recommended way is to use this JSON array. And you basically just, everywhere you probably would have a space in your command, add in an option. So now we're going to have an ls, and we're going to save this. And this time we are going to remove our test image, which was 32 megs, and rebuild the command, the image. Notice it was much quicker because it did not have to copy everything over to the context. And now my command is ls-l, and the reason I did it this way is just to show how I can pass in a command and then a parameter using the array notation. And now when we run this without passing a command in, it will automatically give us the long listing of our image root directory. Okay. Third part here is we're going to talk about we've talked about run, we've talked about command. We're going to talk about two other variables here, WORKDIR and environment, env. WORKDIR basically puts us into our working directory is whatever we define there, which means when we start up the container, we will automatically start in the working directory. And of course, env is just like environment and run. It allows us to set an environmental variable from the build image. Now remember that this is a part of the image, so be careful what environmental variables you set in here. There are some variables that should be set in the Dockerfile, and there are some variables that need to be set at runtime with the Docker run -e option. So once again, let's build this. And I just want to show Docker images. I have several images, and you'll notice here I have these repository none and tag none. What's happened is that as I build images, if I don't tag them, it will automatically make the newest one be latest, and so it will leave these as unknown, kind of untagged. So just be mindful that you could, while you're learning or building an image, create a whole lot of orphaned or kind of not identifiable Docker images. So now we're going to run our program, our container again, and we're going to run bash inside of that. And notice that my present working directory is /root now because we set working dir. And if I echo the DZ environmental variable, which we set in using env, we set it to version 1, I will get a string of version 1. So WORKDIR and env, they just set up the environment help to set up the environment for your image, the containers that run off of your image. Which brings us to the fourth part, which is the run command, or the add command. A lot of times you might need to do several things to set up an environment. Maybe you want to provide a single entry point, or you need to add code, or whatever the reason being, you want to add some code to the image. And what we do here is use the add instruction, which says copy run.sh to /root./run.sh on the container, on the image. Now this is all in reference to the context, which means I can't do a .. That will not work, because remember that the context, the current directory that's getting built, gets copied over and used by the Docker daemon. So .. has no reference to what the Docker daemon is trying to do. So it's always in reference to the current directory that is getting built. And just remember that context, context, context. So we're going to add in this run.sh, and to show you what it is, it's just a simple shell command that will echo out our current working directory, what our DZ environmental variable is, and whether or not we've passed any arguments to our container. And so Got to build this image. And now run this image, but this time we're going to use the default run command because we set it as run.sh. Before we do that, I'm going to clear out. And you'll notice the same information we saw before. Present working directory is root, and our DZ variable is version 1. We didn't pass any additional arguments into this. But if I go and type in /run.sh and then say hello, now I have one argument, hello. Not too complicated. The reason we are doing that is to show this other point here, which is we are now going to talk about an entry point. Now, an entry point may seem a lot like a command, but it's not. An entry point is basically to give you a non-overridable entry to the program. Now, non-overridable is loose because they can pass in a new entry point via command line options when they run the container, but this gives a default binary or package that always gets run on this image. So if you have a Docker image which runs and the containers are just servers and you want it to run the exact same code on every single one of them, then you have an entry point. And when you have an entry point, it's the same as before. You can pass in multiple arguments using this array notation. The other thing here, though, is that if you add in a command with the entry point, the command will get passed in as arguments to the entry point. And you'll notice that the run.sh checked how many args it had. And it said, and it printed it out. So I pass in a command here of arg1, which should get entered into the entry point as a parameter. On top of that, you can only have one entry point per Docker file, which means that if you create a second one, the last one that is created will be used. Go and build our image again. And now when we run, I am not going to pass in anything, and you'll see that it still runs the run.sh shell. But if I pass in something like bin bash, it still runs the run.sh file, but this time it passed in bin bash as a command. So remember, real quick, earlier here, because I had uncommented the arg1, that automatically got passed in as arg1. But in this situation, because I tried to run a command but I had an entry point, it didn't allow me to actually run bash on this. And that's the very, very basics of the Docker build command. It basically allows you to create your own images and install the software you want, set environmental variables, add code, set working directories, entry points. And so this allows you to create your own customizable software inside of a Docker container. And in the future videos, we'll go over some ways to use that. But for now, this is just a very simple overview of the Docker build command. So feel free to ask any questions in the comments below. And thanks for watching this video. Please subscribe and rate the video. Thank you.
Thanks for watching this Dark Zebra presentation. Please rate this video and add it to your favorites if you liked it. For additional content, you can subscribe to our YouTube channel or visit us at darkzebra.com.